Alrighty, for this video we're going to practice how to calculate formal charge using the formula valence minus dots minus dash. And so we'll use this example right here. We have carbon, we have hydrogen, we have oxygen. And so if we're going to build this molecule, first we got to figure out who's going in the middle. So F right here is the most electronegative. And so when we build these molecules, we want the least electronegative, but never ever hydrogen, in the middle. So our least electronegative is going to be furthest from F. And again, we never put hydrogen in the middle. So in this case, it's going to be carbon. And while we're looking at this periodic table, let's figure out our valence. Let's see, hydrogen is 1, carbon is 4, oxygen is 7. And we just count those columns 1, 2, 3, 4, 5, 6, 7, 8, and we skip the middle because they have d orbitals that make their valence complicated. So when we draw this out, we'll put carbon in the middle. We said it has a valence of 1, 2, 3, 4. Let's add in our 2 hydrogens. They each have a valence of 1. And oxygen has 1, 2, 3, 4, 5, 6 electrons in its valence. So hydrogen only wants to share 1 electron because it only has 1 orbital, an s orbital, and the max on that is 2. So since it only needs to share 1, we're only going to draw 1 line. Oxygen has a valence of 6. If it wants to get to 8, it's got to share 2 electrons because 6 and 2 is 8. So to finish that off, we're going to draw 2 lines between carbon and oxygen. But that's not what we're here to practice. We're here to practice formal charge. So we're going to have to do this for carbon, for hydrogen, and for oxygen. So we're going to do valence minus the dot, which is the lone pairs, minus the dash, which is the bonds. So carbon's valence is 4, hydrogen is 1, oxygen is 6. Carbon has 0 dots, 0 lone pairs. Hydrogen has 0 dots and 0 lone pairs. And oxygen has 1, 2, 3, 4. So we're going to put a 4 right there because it has 4 dots around it. So carbon has 1, 2, 3, 4 lines attached to it. Hydrogen only has 1. And oxygen has 2. So you work that out, that gives us 0. We're going to multiply by 2 because there's 2 of these. But at the end we still get 0. And 6 minus 4 is 2, minus 2 is 0. So if we add all of these up, our total charge for the molecule is 0. Which makes sense because this is a stable molecule and this is where it wants to be as far as charges go. So let's look at another one. We have 2 versions of carbon dioxide, and we want to know which one is the most correct based on formal charge. So on this one, we'll do carbon and we'll do oxygen. These oxygens look the same, so we'll just multiply whatever we get times 2. So our valence for carbon is 4. And our valence for oxygen is 6. There are 0 dots around carbon and 1, 2, 3, 4 dots around each oxygen. There are 1, 2, 3, 4 dashes attached to the carbon and 2 dashes attached to each oxygen. So from this we get 0. 6 minus 4 is 2, minus 2 is 0. So all of our charges here are 0. Let's scoot on over. We'll have carbon. We'll do oxygen 1 and oxygen 2. Because we have 2 oxygens that look different. So on our carbon, we have 4, 6, and 6. Those valences don't change. Carbon still has 0 dots. We'll say that this is oxygen 1. And we'll say that the other one is oxygen 2. So oxygen 1 has 1, 2, 3, 4, 5, 6 dots around it. and oxygen 2 only has 2. Oxygen 1 has 1 dash, and oxygen 2 has 3 dashes. Carbon has 4 attached to it. So this gives me 0, that gives me -1. 6 minus 2 is 4, minus 3 gives me +1. So while my bottom line still comes out to 0, this one over here is the better structure because everybody is 0. This oxygen right here is super duper unhappy with the +1 charge because oxygen is super electronegative and it wants to have lots of electrons. We should make it super negative. So at the end of the day, just use this formula, valence minus dots minus dash, and you'll be in the good.